Hello, once again. Welcome to Maths with Mr. Courage. Today we are in trigonometry and we have an identity to prove. And this question is adapted from Northcliffe High School, that is 2022, number 6.4. So it says here, prove that 2 sine cubed x plus sine 2x cos x is equal to tan x, and then this is divided by 2x. So the number of marks shows that there is not really a lot of work to be done, but the order of proving an identity, we choose the left-hand side. So our left-hand side will be equal to, I will write the identity that has already been substituted. So our left-hand side is equal to 2 sine cubed x plus sine 2x cos x all over 2 sine x. But I'm going to start by replacing the sine 2x, since the right-hand side only has a single identity. So therefore, it will be 2 sine cubed x plus the identity for sine 2x. This is 2 sine x cos x, and then there was a cos x there. This will be all over 2 cos x. So that is the first step, replacing sine 2x by 2 sine x cos x. Now, if you can check this expression, we have a common factor here, which is sine x. We also have a sine x there. So this would be equal to, we can even take out a 2. Yes, there's also a 2. So we can take out 2 sine x factor of this one remains as sine squared x, and then plus cos x and the cos x, which gives us cos squared x. Oh, this is nice. It's almost done. Then this is all over 2 cos x. Now, if you notice, sine squared x plus cos squared x, that is the Pythagorean identity, it is equal to 1. Therefore, we will have 2 sine x all over 2 cos x. The 2 and the 2 cancels, and our sine x over cos x is equivalent to tan x, which is our right hand side. So this is the end of our proof for the identity. Then, interestingly, there is part 2, which says, for which values of x is the identity undefined? For which values of x is the identity undefined? Now, this part of being undefined is connected to fractions. A fraction is undefined when its denominator is 0. So in this instance, I am going to take our tan x to say this is tan x, and remember, I'm going to choose tan x. Tan x, remember, it's sine x over cos x. So in this instance, I'm going to use the right hand side, express it as a fraction, so that this denominator clearly stands out. So in other words, this identity that we have is undefined. This is undefined when cos x is equal to 0. This denominator is equal to 0. You could also say it's undefined when 2 cos x is equal to 0. You can choose any of them. Now, when we are solving for this one, cos x is equal to 0. Our x would be equal to, and then if you check the graph of cos, or from your calculator, what is shift cos 0? What do we get? How many degrees? 90. So remember, for our cos equation, we said it's plus or minus. So our x would be equal to plus or minus 90 plus 360 k, where k is an element of a real number. So in general, when x is equal to 90 degrees, and also when x is equal to minus 90 degrees, this identity is undefined. It's very special also if you check the asymptotes of the tangent graph, you find them at 90 as well as at minus 90. So the critical values that we have here, it's x is equal to 90 or x is equal to minus 90 within the domain of minus 362, 360. So enjoy this one. It's a very important question. Then there is another one that we have, number 2. We have a problem here that is given sine p plus sine q is equal to 7 over 5 and p plus q is equal to 90 degrees. Determine the value of sine 2p. Now, when you look at the identity for sine 2p, it is sine p cos p. So therefore, we must introduce a cos here. Now, if you take note, p plus q is equal to 90 degrees. It means that the sine of q is equal to the cos of p, is equal to the cosine of p. This is by co-functions, because these two, they add up to 90 degrees. Now, in order to proceed, we will consider it as follows. Therefore, our sine p plus sine q, we said this is going to be squared, is equal to 7 over 5 when we square. But now we said because these are co-functions, they add up to 90 degrees, we will replace sine q by the cosine of p. Now if we replace, we will have sine p plus the cosine of p squared. This will be equal to 49 over 25 after squaring both sides. Now, a full expansion should be done here. When you expand, we will have sine p plus cos p bracket sine p plus the cosine of p. This is equal to 49 over 25. Now, if we simplify, we will have sine squared p plus, we have here sine p and then cos p. So we will have two things here. Sine p multiplied by cos p. This is sine p cos p. So we will have 2 multiplied by sine p cos p and then plus the cos squared of p. This is equal to 49 over 25. Now, sine squared p plus the cosine squared of p is equal to 1. Therefore, we will have 1 plus, now if you look at this expression here, 2 sine p cos p, this is the identity for sine 2p, which will be equal to 49 over 25. Now, in order to remain with the sine p alone, we will take the 1 to that side. Therefore, sine of 2p is equal to 49 over 25 minus 1. And then when we say 49 over 25 minus 1, what do we get here? That would 24 over 25. That will be our final solution. This reminds me of another problem that is normally in algebra. When you have an expression like x plus 1 over x, let's say this is equal to 2, and you want to create another expression out of that, you normally square both sides. If you square both sides, you will get an expression that is going to clear this part that you have here in algebra. There's also another question in algebra that normally comes or towards the end of question 1. So the key here is problems like this, where you are creating something from this part like in reverse. You can get that by squaring both sides, and then you make use of the different clearing methods, which can be identities or just basic expansions when you are in algebra. This is a very, very important question, and make sure you practice more on these questions where you are reversing and applying these identities indirectly to get your required reductions. Don't forget to like, subscribe, and share. We will be focusing more on those challenging questions that will be towards the end of each section, improving identities, in solving equations, as well as even the 3D that will be in our next series. Thank you.